Welcome. Today we're going to look at composite functions, so go ahead and get your notes out and we'll get going. Remember during the video, if you're falling behind in your notes, to pause the video and make sure you stay caught up. And if you didn't quite understand something the first time, stop the video, rewind it, and listen to it again. Sometimes it takes a couple times through to understand the concept. Okay, let's go ahead and begin. So let's talk about composite functions. Now, composite functions have a lot of everyday use. Okay, so here's a relevance problem. It talks about a store, and the store is having a $50 off every purchase sale on February 8th. Okay, so here we are, we're going to the store, and on February 8th, they're taking $50 off the purchase price of whatever you buy. And I can illustrate that function down here in part A. And part A says this is the February 8th price, where X is the original price. So if I went X, the original price, minus 50, that could be our function for our sell price. Okay, the store also has a policy that gives a discount of 15% off the original price to any veteran. Okay, so here's my veteran discount price. So if you're a veteran, you can come in any day and you'll take the original price and subtract away 15% of it. And that'll be your veteran discount. So we're going to write a function that shows the amount veterans will pay on February 8th. If they go into February 8th, then they not only get their February 8th price, but they'll get their veteran discount as well. And that's shown here. This is the function for the veteran on February 8th. And all you simply see is we took the veteran discount first and then take away 50. Essentially what we did is we took this whole function and we plugged it into the other function. We took out the x and we put in, we'll circle the whole thing, x minus 0.15x. Okay, so that's one function in the other, and that's what a composite function is. So you didn't quite understand the relevance problem? When I come to class, we're going to talk about it again. The key concept is there is relevance to this, there is a reason, and we're talking about plugging one function into the other. All right, let's start our problem. So this is our first example. We're given two functions. Let f of x equal 2x plus 3 and g of x is equal to x squared. We're going to build a composite function using these two functions. Take two functions and make one. So the first one we're going to look at is what we call f of g of x. One more time, that's f of g of x. And there's the notation. Okay, it looks like it spells fog. It's f of g of x. If you don't know how to say it, make sure you write that to the side verbally. F of g of x. Okay, so the notation, the first step is we're going to rewrite it in some more familiar notation, and we're going to call this guy our inner function. The second one is always the inner function, and we plug it into the first function using a substitution or evaluation. So we're going to say this is actually f at the inner function, g of x. Okay, so it's just notation from here to here, understanding this notation and how it goes to here. And this simply implies that we're going to take the g of x function, which we know to be x squared, and evaluate it at f. Okay, so now I'm going to simply go like this. Write our f function down. This is 2 evaluated at, and I'm simply just going to write g of x in here still. So I took out x and I put in g of x, because that's how we evaluate, plus 3. So you have to see the substitution. I pulled this x out and I put in the g of x. Okay, lastly, we know that g of x is actually x squared, so I'm going to substitute in, instead of g of x, I'm going to write it as x squared plus 3. And there's our composite function. I plugged x squared into 2x plus 3. All right, let's take a look at a different example. Using the same two functions, we're going to reverse it and go the other way. So this time, my f of x function is the inner function that's being plugged into or substituted into the g of x function. So with notation, my g comes first. He's on the outside. My f of x function is on the inside. Okay, this is actually g at f of x. So we just kind of modeled. Now, on the first example, I substitute g of x. I'm going to show you a different way. If you didn't quite see it this way, I'm going to show you a different way to do it here. So instead of writing the problem out, I'm going to do another substitution here. I'm going to write g, still my outer function, and I'm going to substitute in the value of f of x. Now, because f of x is 2x plus 3, let me give myself a little more room. I'm going to take f of x out and put in my 2x plus 3 here. Okay, now I'm going to evaluate g at 2x plus 3. Well, since g is x squared, I'm going to pull out the x and replace it with 2x plus 3, and that would all be squared. And remember, in your function, this was the original x that we substituted out right here. Okay, so either way will work. You're going to have to find the way that works best for you. And again, this is just substituting one function into the other. Now I notice g of x, we're not quite done because I can square this. So I'm going to go ahead and square this quickly. This is 2x plus 3 times itself, which equals, using FOIL, we'll use, or multiplication of two binomials, we'll get 4x squared plus 6x plus 6x plus 9, which equals 4x squared, so here's our composite function, plus 12x plus 9. Okay, we looked at two different cases. We put g into f, we got 2x squared plus 3. Then we looked at the other case, well, maybe f of g. We got 4x squared plus 12x plus 9 is our composite function. And that's not the only thing we can do. What would we do if we plugged f into f? So go ahead and pause the video and give it a try, and then I'll work out the solution. So go ahead and do that now, and when you're done, turn the video back on. Okay, here's what you should have done. Again, it's identifying the inner function. The second one's always the inner function. The first one's always the outer function. So it looks like, rewriting this, this is going to be f with itself, f of x, evaluated or plugged in. Okay, so I'm going to go ahead with the second example way. I'm going to pull out the f of x and substitute in the 2x plus 3. Here we go. Okay, so I want to evaluate f at 2x plus 3. So I'm going to write, and this time I'm going to do my substitution in red. So my f of x function is 2x, but remember I'm replacing x. I'm going to give parentheses to write in my substitution, plus 3. And my f of x function, or 2x plus 3, I'm going to plug in where the x was, and then with a simple evaluation I can say, distributing through, my composite function will be 4x plus 6 plus 3, which equals 4x plus 9. Okay, so again, this is all about seeing the substitution, which is the inner function, plug it into the outer function. Once you see that, this becomes very simple. It's all about evaluating. Okay, to finish up your notes, and this is what I'm going to need to see, and I will be checking these for points along with the examples. So I want you to briefly explain in your notes the process we used to find the composite function. So give me a general summary on how we find a composite function. Use vocabulary. You can use the inner function and outer function. And remember, use words like f of g of x and so forth. And I'll be checking these as when I come back. Okay, so if you have any other questions, write them down in your notes and we'll handle them in class. Thank you.